respected speaker of today's session, dear participants. A very warm good morning to all of you. I, Dhanesh Patil, Assistant Professor, Electrical Engineering Department, welcome you all once again on the fifth day of AICT sponsored 1 week HTTP on digitally controlled power converters for industrial application phase 3 under AQIS scheme. From the last 4 days, we are being updated by various resource persons on the topics. Today, we have with us two eminent personalities as a resource person. Dr. PJ Shah, the convener of this FDP and professor, ENTC department, and Mr. M. Ansari, assistant professor, electrical engineering department, who are going to share the today's session. I take this pleasure to first introduce Dr. PJ Shah sir. Dr. PJ Shah, professor in Electrical and Telecommunication Engineering Department, has been awarded his PhD degree in Power Quality Improvement and Filtering Technique in Power Supplies from Shri Govindram Sekaria Institute of Technology and Science, Indore, under RGPV Bhopal in 2014. He has received the Bachelor's in Industrial Electronics from Amravati University, and he is completing his Master's in Power Electronics from SGSITS Indore in 1997. He has also qualified Diploma in Business Management, Master of Management Science from Pune University. He is also recognized as a PhD guide in Electrical and Electronics Engineering of KBC North Maharashtra University, Jalgaon. He was also Chairman, Board of Studies of Electrical and Instrumentation Engineering at KBC NMU, Jalgaon. He has published 50 plus research papers in international journals and conferences like Springer, elsewhere, and also written few books. He has also reviewer of many international journals and conferences, which includes IEEE Transaction on Power Electronics, IET Power Electronics, IE International Conference on Engineering and Technology, organized by Faculty of Engineering of Prince of Songkhla University, Thailand. The total experience is nearly 30 years. He was also working as a professor and head in electrical department from 5.5 years. He has established MOU with very renowned industries for the development of students and faculty members. The MOUs he's tried are with Prince of Songkhla University, Thailand, National Infotech Surat, COET Solution, IIT Mumbai. Under his tenure, he received the grant from AICT of rupees 3,66,000 for conduct HTTPs on digitally controlled power converter for industrial and renewable application under AQIS scheme, which we are going through. He has also organized many FDPs. He is also honored by Shiksha Ratna Puruskar and Super Genius Award. And he is also the member of IST and IE. So I request Dr. PJ Shah sir to please continue with the session. Over to PJ Shah sir.
Thank you, sir. Thank you for nice introduction. Okay. Okay, once again, good morning. This is the phase 3. I have already delivered 2 lectures in phase 1 and phase 2. So today's topic is analysis of power electronics converters of photovoltaic system. In this topic, we will cover a basic system, a photovoltaic system. Different types of power converters are used, like choppers and inverters in a complete system. So we will see the details analysis of the choppers as well as inverters. And before that, I will give you a basic ideas of power semiconductor devices before starting the converters. Okay, let's start with the first slide. So in this slide, you can see this is the basic photovoltaic system. Generally, we are using a few components in our photovoltaic system, our PV array, our power converters. You can see here, power converter unit. Minute. So this is the PV array, and this DC, this DC we will convert into the AC, and this output AC we can give to the load, or we can feed to the grid. So there are basically we are using two types of inverters: standalone or grid fed inverters. So if you are using standalone, then we can store our DC power into the battery. Then we will be need of two types of converter: DC to DC and DC to AC. So basic requirement of inverter is required a regulated DC. Inverter is required regulated DC, and DC received from the PV array is basically unregulated, depends on the light incident on the PV arrays or our solar panels. So this DC we can regulate with the help of DC to DC chopper. So maybe a step up or step down. Chopper we can use here for two purpose. One is this output of chopper we can give to the input of inverter. That input of inverter will be regulated. Second thing, we can also use this chopper to charge the battery. For the storage system, we can use the DC to DC chopper, but the role of chopper is different. So in upper case, it will regulate the DC voltage or magnitude will be regulated. In lower case, you have to use this chopper as a current regulator. Means that particular current controller we can use to regulate to charge the batteries. This is the basic system, and we are using this system. This is one example. I have taken one example. So in this system, we are using a DC to DC converter along with the MPPT controller. So this is one converter, power converter, and here the battery charger you can see. So this battery charges also a DC to DC converter, but it controls the current, and here it controls the voltage. So input to the inverter is basically fixed. If input DC is not regulated, inverter will not give the proper output as per the our application, as per the applications. So here just I have taken the example. Suppose I need I have received a 36 volt from the solar panel, but I need a 400 volt. Then I will convert this 36 to 400 by means of boost converter or DC to DC step up chopper. And this regulated DC we can give to the inverter. This is your inverter, and this inverter is converted into the adjustable, it's converted into the AC. Basically what happened, these inverters are basically two types, PWM or square wave type, but generally we are using the PWM square wave. Here we can control magnitude as well as frequency, and this output we can give to the respective applications or load, or we can feed to the grid. And main important part of this our solar system is microcontroller or just control in it. This is the microcontroller. So this particular microcontroller we can use it. A role of this microcontroller is it gives the control signal to the chopper, inverter, as well as your battery system, and it take the feedback from the output, and accordingly it compare the reference value with the compare the reference value. It provide the particular controlling signal to the switches used in the choppers as well as inverters. So this 36 volt I have taken here value, but this value is not fixed. It depends on the light incident on the panels. So maybe 24, maybe 50. This values varies, but output should be fixed. Outputs of this regulator should be fixed. So how it can possible? So here we can adjust the duty ratio of the respective chopper. So example, the formula for DC to DC step down chopper is output voltage is equal to duty ratio time into input voltage. So the input voltage is VD. So here the output voltage is fixed 36 volt. Okay, but my input voltage is suppose 72. I am getting 72, and my my duty ratio is 0.5. Then I will get 36. But in the case of sorry, 1 minute, 400. Sorry, here 400. This is the case of step down chopper, but in the case of step up chopper, the output voltage is 1 upon 1 minus D times input voltage. So here we can adjust the duty ratio D. Suppose my input voltage is 36 and I need output voltage is 400. Accordingly, I can adjust my duty ratio. Okay. So these are the two basic system we have seen, but in the next slides we will see basic chopper converter, its analysis. क्या क्या पूछ 1 minute क्या पूछा है?
Means we can vary duty.
Yes, I'm unable to see the chat. As I read the question, means we can vary the duty ratio. Output voltage of the chopper we can vary with the help of duty ratio only, because output voltage we need a regulated or constant. Okay, but input voltage is our input voltage is flexible. Is adjustable due to the variation of input voltage. It affect on the it affect to output. So we can adjust the duty ratio. Okay. So we'll start. Before starting my next topic, so I thanks to all these authors of these books. Ned Mohan is a very good book we can use for the application point of view. Ramamurthy is the basic book of it is used for the fundamentals. So from my point of view, these first two books are very best for fundamental. For fundamental, 1 minute. For fundamentals, Ramamurthy's book is very best. For application on analysis, Netbone books is very best. Okay, so these are the basic books. Then Rashid, I have referred Rashid's book also, P.S. Bimra's book also, and you can also use Dr. Shailendra Jain's book, Modeling and Simulation using MATLAB Simulink by Willy India. So these 5 books I have referred, and some papers I have referred. So again, I am starting the different power converters with the block diagram of power electronic system. So I have already shown you this block diagram in the my first lecture in first page, but there are some new participants. So 5 to 10 slides I have repeated. Okay, so we have just seen here in any renewable applications. In renewable applications, suppose I am using solar system, I will be need of 2 types of power converters. One is DC to DC chopper, other is inverter. Suppose I am using a wind turbine, or I am converting wind energy into the electrical, I will be need of AC to AC converter, or first we convert in AC to DC, then again convert in DC to AC. Means here we can use AC to AC voltage controller either, or rectifier plus inverter. Okay, means all types of converters we are using in power electronics. There are 4 types of converters. First is you convert AC to DC. Second, you convert DC to DC, or you convert DC to AC, or you convert AC to AC. So these are the 4 types of conversion used in power electronics. So AC to DC, a simple AC to DC rectifier. DC to DC is simple choppers. DC to AC is inverter, and again AC to AC is AC voltage controller. Means all 4 types of power electronics converters used in renewable application. So they plays a very important role in renewable application along with their digital control system. So that's why here I am going to start power electronic system. So in phase 1 we have discussed rectifier, and in this phase 3 we will see choppers and inverters. So I will cover two converters, choppers and inverters. So this is the basic power electronic system. It contains two blocks, power processor and controller. Power processor is simple according to definition. According to the definition, power electronics is to process and control the flow of electric energy by supplying the voltages and currents in the form of that optimally suited for the user's load. Means my available input is one type, my output load is another type. Example, my load is DC machine and available input is AC, then I will be need of AC to DC conversion. And another, suppose my input is DC, output is also DC, then I will be need of DC to DC conversion. Means main use of power processor is just convert one form of energy to the another form along with the control system. And this main function of controller, it just measure the output and it compare with the reference, and accordingly it generate the control signals, and that control signals will be given to the respective power converter or their power semiconductor switches. Example, I am using suppose thyristor. So uh, this thyristor will be receive the gate signal as per the requirement. Okay, so this is complete the power electronic system, and this power processor is made up of number of converters as well as energy storage elements. So this is
Sir,
the power
excuse me,
process.
sir,
Yes.
one. Sir, what is the reference value that we are going
Hmm.
to take? Means, will it be according to a need?
Appl- according to application. According to application. So
Okay.
reference means what? This controller is having a two part. One is comparator, and other is amplifier, error amplifier, and other is comparator. So what happened? Suppose I have to fix my DC voltage at 100, for example, at 100 volt. Okay. So then, so means for 100 volt, I will be need of duty ratio is suppose 50 or 50%. So accordingly, I will fix my reference value. Means uh, my uh, my output voltage changed to 120. Okay, and I need 100. My reference is 100. This means 20 volts is increases. So then I have to reduce this 120 to 100 by changing the uh, by changing the control signals. Means by changing the output. Suppose my example is rectifier. Then I will decrease the firing angle alpha with respect to thyristor. Okay. So reference means what? I have fixed my particular load voltage at particular value, that will be reference. So that reference we will give here. Suppose my reference is 100 volts and my change is 120 volts. Okay, this voltage is actually this is changing value or adjustable value. So this value may be 120 or this value may be 80 volts. So suppose this is 80, then I will boost it. It is 120, then I will buck it. Got it?
Okay, sir. Got it. Yes, sir. Thank you.
Uh-huh. So I will give one example at my next part. I will give that example. And just I have to go fast for the this basic slides. I want to come on my main application, that is chopper. This power processor is made up of one converter or number of converters, and along with the energy storage element. Basically output voltage, I just told you in previous slide, maybe DC or AC. If you talk about power electronics, we will play in two different categories only. Your output will be AC or DC, your input will be AC or DC. Just I shown you the previous conversion flow diagram. So if my output is DC, it should be regulated, it should be adjustable. So for regulated, my example is switching mode power supply. So SMPS we are using in various applications. For example, television, our electrical or electronics appliances, computer systems, etc. So where the the input voltage for the SMPS will be needed constant DC. Okay. And adjustable magnitude, suppose I want to control the speed of DC motors. So suppose I want to control the speed of DC motor, I will be need of adjustable DC. So this adjustable DC we can give to the respective applications. Okay. Then AC, if you talk about AC, maybe magnitude is adjustable, but with along with constant frequency, or both will be adjustable. Okay. So for that we are using AC voltage controller, and suppose for the speed control of induction motor we are using, suppose V by F control. If uh, this particular control if you want to do, then we will use this another, that is B, and B is the cyclo converter. So cyclo converter, output of cyclo converter, or with the help of cyclo converter we can adjust magnitude as well as a frequency. But in the case of AC voltage controller, a best example is fan regulator. In AC fan regulator, means in fan regulator we can control only magnitude, but frequency is 50 Hz constant. Okay. So same thing we are using in our photovoltaic solar system or renewable applications. So accordingly we can choose our converter. Okay. So this is simple flow of converter, how it convert AC to DC or DC to AC, and we are using in various applications. I have already discussed in first page. So we'll start with the devices. Actually, power semiconductor devices are categorized in three types according to their turning on and turning off system. There are three types. One is power diode, second is thyristor, third is controllable switches. Power diode means how they turn on and turn off. Power diodes are turn on and turn off by power circuits only. Okay. So efficiency of this power diodes are very less, or this particular you are using power diode in particular application will be very less. Second category is thyristor. We can turn on by control signal by application of small gate voltage or gate current, and but turn off by power circuit. Same with the power diode. Means it is half control, means we can turn on by power circuit but turn off OFF by turn off by a power circuit. Okay. And in this case efficiency of this particular circuit will be better than power diode, and flexibility we can get here. Means example, if you want to control the speed of motor, so we can control. If uh, you want to maintain output voltage constant or variable, we can do with the help of thyristor in a particular power converter. And basically thyristors are used in AC applications only. Means I just told you power converters are four types: AC to DC, AC to AC, DC to DC, and DC to DC. Where the input is AC, that is AC to AC, and AC to DC are the AC applications. Okay. So if inputs are AC, so because of that power blocking capability is available in SCR or thyristor family only. We can block thousands of volt with the help of SCR, which is not available with the controllable switches. But these AC applications means they are low frequency application. Means we are using we can use these particular devices in 50 Hz frequency applications. But if we talk about the controllable switches, they will trigger a turn on and turn off by a control signal, but they don't have a blocking capability. It means we can use SCR in all four applications, but IGBT MOSFETs are the example. We are used only in two applications, that is chopper and inverter. Chopper and inverter, so we don't have any option. We can use sorry, IGBT MOSFET is having no options. We can use in chopper and inverter. Means we could not use in AC to DC rectifier or AC to AC controller or cyclo converter. And second thing, limitation of these devices is their current handling or power handling capability. They are available. IGBT is available up to 1200 volts, and I think it's around 100 ampere. But here the SCR is available in 10,000 volts as well as 10,000 ampere applications. Okay, so these are the devices basically. So this is the brief I have shown you. Now I will show you a few devices. You can see. So this is IGBT. This is a simple diode, a power diode you can say. This is thyristor. SCR is having a 3 terminal. One is anode. This is anode. This is cathode, and this is a gate. Also, these are the devices. So this is, you can see. So this is also a device, a silicon control rectifier. SCR is having a 1000 ampere. You can see this is the side of anode, and this is cathode, and this is gate. You can see in photograph also. You can see here. So here is the anode. Here is the anode, and this is the cathode, and one small terminal, that is the gate. And one device. This is the IGBT. So MOSFET and IGBT is also available in a same structure, having a 3 terminal. This is also MOSFET. Okay, so these are the devices, but this device you can see R125 1275N S21 inverter fast SCR thyristor. It means, so these thyristors are also manufactured with a small turn on and turn off time, and basically we can use this thyristor for the inverter application, because thyristors are having a 1000 volts withstand capability as well as thousands ampere current handling capability. Because of that, thyristors are very popular in that particular applications. Now come to the chopper. Now this is the chopper. Choppers are basically used to convert DC to DC. So input DC may be adjustable or output DC may be adjustable. One of them is regulated and one of them is adjustable. So for that we are using two types of control schemes. One is a constant frequency control, other is the frequency modulation. So constant frequency control is also called a PWM control. So here frequency is fixed. We can vary on time. We can vary on time or off time. So in this particular method, this constant frequency control method, so output voltage can be vary by the help of on time. So this is example. So this is the on time in the case, and this is total time t. But if I want to vary the output voltage, I will vary duty ratio. It means I will vary on time. So I can vary on time, but my total time, one cycle period will be fixed. So as you know, the duty ratio is T on upon T. Okay, this is the definition of duty ratio. So if I vary on time, my duty ratio will be means we can vary the duty ratio. Second is variable frequency. Means in the advantage of this method is due to the fixed frequency or constant frequency, filter designing will be simple. Okay, but in second case, variable frequency method, in variable frequency method, your either on or off time will be fixed or constant, but other time we can vary. That is called frequency modulation. So this is the example. Here my on time is fixed, but I am varying off time here. So here my on time is fixed, but I am varying off time here. But in both cases, time t is here more than this case. Means here frequency is higher than this case. Similarly, here off time is fixed, but I have vary on time. Mean in the all cases my frequency is varying, but in this case one advantage is we can get the wide area for variation, but filter designing is very difficult because value of frequency is not fixed. Because of that, filter designing will be difficult. And this is the basic block diagram of DC to DC converter. In this block diagram, you can see, so again, I will give the example of switching mode power supply. In SMPS, suppose again I will give the example of our personal computer. So I am using this SMPS in my personal computer. So input is your AC, maybe single phase or three phase, but first it's converted into the AC to DC by the help of a diode rectifier or uncontrolled rectifier. But that DC may be unregulated. Why? Because my AC is fluctuating due to some reasons. That DC is unregulated, and this DC we can give to the respective chopper circuit through the filter. So first we can uh, remove the ripple contents from this DC. That's unregulated DC will be given to the DC to DC converter. Suppose this is my SMPS. Suppose I need 100-volt DC constant, and my input voltage is suppose 150 volts. Okay, then this controller will play the important role. Okay, suppose I am using a step down chopper, then we know the formula, that is V is equal to D into V in. Okay, so output voltage we need 100 volt, but my input voltage is 150. Accordingly, I will set my duty ratio. So my duty ratio will be 100 upon 150 or 2 by 3. So I will set. For example, I need my 100 volt constant, but my input voltage varies from 150 to 200. Okay, even though my output voltage should constant, means it will not affect the my personal computer or internal component of personal computer. So in this case, what happened? My duty ratio will be changed automatically. So I already shown you the block diagram of the control system. The reference value is fixed, then it compare with the adjustable value. So in this case, my D will be here. So output voltage is 100 fixed, and input voltage is changed to 150 to 200. Then my D will be equal to 100 upon 200, means 0.5. My duty ratio will be changed from 0.66 to 0.5 automatically by help of this control system. Okay, so this is the role of our control system in a particular DC to DC conversion system. Second thing, we have shown here battery. So this battery is also there. If I am not using my input AC, then battery directly give this DC is directly given to the chopper, and we can change the output voltage accordingly. So example is our laptop. In laptop, we are using the battery, and output we are needed constant. Now come to the our basic circuit. This is the basic circuit used for the chopper or step down chopper. So this is the switch. So this switch is your controllable switch, either IGBT, MOSFET or GTO. So along with this, it belongs to the family of controllable switches. In this switch, when switch is on, this input will be passing. Switch is off, no input will be at output. So this output just we can control with the help of duty ratio. Okay, and I am taking here example of PWM controller. So this is the PWM controller. So you were asked me the question, what are the internal components used for the controller? So these two components, one is error amplifier, other is comparator. These two components are basically used. So you can see that it having a two inputs, VO desired and VO actual. Okay, desired means a reference, means I need my output voltage 100 constant, that will be desired. And actual means due to the variation in AC supply or input supply, output voltages also varies. means actual value of a current value of that output voltage. This both value will be compared. So I am need 100 and I am getting actual value 120. Then I have to maintain at 100. So for that, so this is the role. This is the error amplifier. It find the difference between these two. Suppose difference is 20. Accordingly, it generate the control signals, V control, and this control signals will be given to the respective comparator, and comparator compare the repetitive waveforms with the controller. It compare the repetitive maybe it's a sawtooth or triangular. These two types of repetitive waveforms used, and accordingly comparator compare them and it produce the switching signal. Example, this type of switching signal is varying between 0 to 5 volt. So here the switch is on, here the switch is off. In this way it produces the signals. Okay, so here you can see this is the sawtooth. We are compared with the DC line. Okay, this is V controller, or this is the output of error amplifier. So it's given here. So this value is maybe vary. Suppose this difference is 20. Suppose this is the value. So difference is become suppose this value becomes 110. So it will be going down like this, and accordingly your on time will be decreases. So this is your on time. Okay, so my values reduces, difference between the desired and actual is reduces, on time will be reduced. Okay, means duty ratio will be automatically reduced and it maintain output voltage constant. Okay, so when it was 120, when it was 110, accordingly my duty ratio was changed. Okay, so this is the role of PWM controller. Now come to the basic step down DC to DC converter. This DC to DC converters is having two drawbacks. Number one, so just this is the circuit. This circuit is having two drawbacks. Basically, we are using inductive load, but in a resistive load is also associated with the stray inductance. Means when your switch is on and we are using in high frequency application, means our switch is on and off 10,000 times or more than 10,000 times in 1 second. So in this case, this inductive energy will be absorbed or dissipate with the help of this switch, and because of that switch may be destroyed. Okay, whether your load is inductive or your load is resistive. In resistive load is also associated with the stray inductance. Okay, stray inductance, and because of that this inductive energy will be dissipated or absorbed by the switch, and in 1 second our switch will be turn on and turn off 10,000 or 1,000 times, and because of that switch may be destroyed. This is one drawback. Second drawback is output is fluctuate between, you can see here, output is fluctuate between a DC voltage and 0, is fluctuate between VD and 0, and this type of, here you can find a gap. So this here this type of output is not suitable in many applications. Okay, so these are the two drawbacks. So how to remove this two drawback? By using this diode. This we can use this diode here. We added this diode. This inductive energy problem we can remove by this, by adding low pass filter is associated with inductor and capacitor. That with the help of this we can remove the second problem. We have just discussed the second problem, that is output voltages fluctuate between VD and 0, means output voltage will becomes a constant. So in this way we can use these two components, that is feedback diodes, other is low pass filter. Okay, you can see the harmonic generated, and this is the characteristics of the low pass filter. So to remove the ripples we have to maintain the corner frequency. So this is called corner frequency. This corner frequency should be very less than switching frequency. Are you aware with switching frequency? Switching frequency means my IGBT switch or MOSFET switch is turn on and turn off 1,000 times. Suppose my switching frequency is a 10 kilohertz. Okay, and my this frequency should be less, then my ripple will be reduce. So this is the requirement. And this step down DC to DC converters is operated in 3 modes. One is continuous current mode, second is boundary between continuous and discontinuous mode, and third is the discontinuous mode. So here you can see, if you analyze the circuit, this is your basic circuit. When switch is on and when switch is off, we can get the two equivalent circuit. So these are the two electrical equivalent of the circuit. When switch is on, your inductor voltage, inductor is connected to the input side. This input current and inductor current will be same. And when the switch is on, inductor voltage will be Vd minus V. You just apply the KVL. You can see here. You just apply the KVL in this loop. You will get this voltage Vd minus Vo. And second thing, when switch is off, then output voltage. If switch is off, there will be disconnection between the input and your circuit. Means output voltage will be, or inductor voltage will be the output voltage, but output minus Vo. VL will be minus Vo. So in this case, you can see. The out during one period, one integral period, inductor voltage becomes 0, and accordingly you can calculate the voltage across inductor when switch is on and when switch is off. Here we have drawn the inductor average value, this inductor current. This is the peak value, and this dotted shows the average value. This is the average value. Okay, if my this average value is like that, then my case is continuous. Okay, I will show you the second case, discontinuous. This is the edge, or this is the boundary between continuous and discontinuous. So in this case, you can see at the edge of off time, inductor currents becomes 0. Okay, and here two cases we will analyze. One is Vd constant, other is Vo constant. So Vd constant means my motor speed control of motor application. My input DC is constant, output voltage is adjustable. Vo constant means a case of regulator, SMPS. So in spite of variation of input voltage, output voltage Vo is constant. So two cases we will analyze, and if after analysis we can find a maximum boundary inductor current with a boundary case will be this will be obtained at 50% duty ratio. Okay, so it means my TS is constant, my on time is constant, my VD is constant. Okay, but even duty ratio is also set. But if my average value of inductor current decreases, it will decrease the inductor current, input inductor current. If input inductor current decrease, and it will be discontinuous. Okay, you will find a discontinuous current. Means if my output power reduce, it means my load resistance increases. In this case, inductor current will be discontinuous. So this is the case of discontinuous. Okay, so this is the part of discontinuous. Okay, and after analyzing, we will get two cases. One is a Vd constant. This is the case of Vd constant. So this particular hatch part is a discontinuous part. Suppose I want continuous part, I will set my duty ratio in outer part. If my duty ratio in this inner part, then my case will be discontinuous. Dotted line shows the boundary condition. Okay, and this is the second, when Vo constant. Okay, this is the function of ratio IOB, LB, ratio of IOB and LB max is the function of this, and this dotted line shows the boundary case. Okay, this is discontinuous and this is continuous. So if your ratio Vd by Vo ratio in this particular range, your case will be continuous. Means continuous discontinuous mode is depends on the output power, or your input current, or your input average current. Okay, is not depends on time or duty ratio. These are the constant values. Okay, and similarly, we can calculate your filter. We can design the filter. This is the overcharge of filter I have shown you. Now come to the second case, that is step up chopper. Okay, in step up chopper, inductor is the main element to boost the voltages, and is connected to the inside, and these are the two equivalent circuit of the step up chopper. As you know, the output voltage is equal to 1 upon 1 minus d times input voltage. Okay, means if my duty ratio is 0, then output voltage will be equal to input voltage. If my duty ratio is 1, then output voltage will be infinite. Means my output voltage is varying between Vd to infinite. Means output voltage is always more than the input voltage. So that's why it's called step up chopper or boost converter. Okay, so this is the case of continuous conduction mode. This is the case of boundary condition mode, and here again two different analysis I have used, one for IOB and one for ILB. ILB means inductor current with the boundary case, IOB means output current with the boundary case. So if I consider the ILB, so I will get a maximum value of the this inductor current when duty ratio is 50%. If I am considering IOB, I will get maximum value at 33% of duty ratio. And in the same cases, you can get the discontinuous if my inductor current average value of inductor current reduces or output power reduces. And these are the different uh, um, cases. One is the discontinuous, other is the continuous. Okay, and the parasitic element, is depends on the losses of the inductor and capacitor. So this is the parasitic. Other type is the full bridge DC to DC converter. Suppose I want to control my DC motor in 4 different quadrant. One is motoring mode, one is regenerative braking of motoring mode, or reverse motoring mode, and regenerative braking of the reverse motoring. So if I want in my application I am need of 4 different quadrant, that is 4 operations, then I will be choose a full bridge DC to DC converter. This is one application. This is also one type of chopper. Okay, so we can use this chopper in 2 different switching methods. One is bipolar, other is unipolar. We don't have much time. Now I will come to the inverter. Okay, second device used in our solar system is DC to AC inverter. So inverters are basically classified three way. One is depends on input, second is depends on output, third is depends on control scheme. Depends on input. See, my input is voltage or current. Okay, so maybe voltage source inverter or current source inverter. If my output is single phase or 3 phase, then single phase inverter or 3 phase inverter. Third is a control scheme. 2 types of control scheme basically used. One is square wave, other is a PWM. So we can call square wave inverter or PWM inverter. Okay, so basically this is the for driver applications, by using one rectifier, then this constant DC will given to the respective inverter. But here only magnitude may be controlled. Suppose I am changing this diode rectifier by a thyristor rectifier, then I can vary magnitude as well as frequency. Then we can get a switching mode converter. There are the basics. One is PWM, I just explained. Square wave is also there. Basic concepts. Suppose in inverter, we can operate this inverter is also 4 mode. Inverter also used as a rectifier. I also told you rectifier also used as an inverter. It depends on the condition of input voltage and current. So in first case, my voltage and current both are positive, then I will operate as an inverter. In second case, my my current is positive but voltage is negative. Okay, will be operated as a rectifier. In third case, both are negative, will be operated as a inverter. In fourth case, my current is negative, current is negative and voltage is positive, will work as a rectifier. Okay. Basically, three types of inverters were using half bridge, full bridge, and a three-phase bridge. In half bridge, we are using the switches, two switches, and your supply is just VD or 2 VD by 2. We are using a 3-wire supply use. Feedback diodes are used when your load is inductive to protect the device. Okay, when a particular current immediately change from a positive to negative or negative to positive. In this case, suppose my particular device SCR or IGBT it changes immediately with that particular rate, and rate of change of current required current and according to data sheet will be higher than that, then my device will be damaged. So these are the different rectifiers used. So this SCR is responsible to get the positive cycle, and this SCR is responsible to get the negative cycle. Okay. So this is the output of square wave inverter, and this is the output of full bridge square wave inverter. But basic difference is here the two SCRs are conducted at same time with the same input. If you compare with the half bridge, your output will be double. Output voltage will be double. Okay, and these are the protective diodes. Okay, if my load is inductive, then this diodes will be operated. This D1, D2, this diodes will be operated. So just example, suppose I am getting output voltage is positive, but due to the load, my output voltage is changed to positive to negative, but current is still positive. If current is still positive, you can see here my current is still positive. In this case, you can see the direction of this particular device is, you can see here, is opposite. So in this case, what happened? When 1 and 2 will be off, but 3 will not turn on immediately because of the rate of rise of current is different. To avoid that, this diode will be conduct. If diode conduct, it will turn off the respective diode, and when after this negative part will be this negative current will be changed to 0. In this case, the diode will be off. If diode will be off, this T3 will be on immediately. Means D3 will be protect T3. Okay. So these are the different inverters, three-phase inverters. We also use two types of modes. One is 180-degree mode and one is 120-degree mode. Actually, due to the time constraint, I have to go fast. This is 180-degree mode. Okay, so you can get a 6-step square output or Cauchy square output. This is your line voltage and this is your phase voltage. Similarly, this is the 120-degree. In 120-degree, this is the Cauchy square and this is the 6 steps. So in this case, what happened? Because of that, 120-degree mode, so you can get the blank time. One important thing, in any types of inverter, these two switches are connected in one leg. These two switches should not turn on at same time. Suppose T1 will be turned on, after the end of T1, this T4 will be turned on. But when we are turning on T4, but T1 turning off of T1 is fail, with both devices will be turned on same time, and it will short circuit the source. To avoid that, in 120, it may be possible in 180-degree, but in 120 we added the blank time between these two. But what happened? In 180-degree, three devices are turned on at same time. One is connected to A phase, second is connected to B phase, and third is connected to C phase. But in 120-degree, only two devices are connected, means either or only two devices are connected to two phase. For example, they connected to A and B phase. Then C phase is, in this case, no load is connected to the C phase. So the analysis will be very difficult. Okay, and last category is the PWM inverters. PWM inverters, you can see here we are using the triangular waveform, and compare with the AC. this repetitive waveforms are triangular. So here, if you compare this, you can see here. If I compare, this is for that you just remember I have shown you the PWM controller. We can give this two input to the comparator. I have shown you the comparator. So one input is V controller and other input is the repetitive here, and this is the comparator. And V control comes from our error amplifier, and input of error amplifiers are desired output and required actual output. Okay, so same thing, instead of that sawtooth, I have used the triangular. And here you can see when your switch is turn on and turn off multiple times during one output cycle. It means frequency or switching time should be fast. Okay, so that's why high frequency switches are used. Okay, but important thing is, if output is square, it will actually basically our AC appliances are designed for the sinusoidal input, but if you apply the square, it will affect the particular AC appliances, that other AC appliances will be damaged. If the output is this PWM sinusoidal, means shape output voltage varies exponentially, you can see here. So this is the fundamental value, and they changes exponentially. Okay, so that's why this type of outputs are suitable to the AC appliances. Okay, so this is the case of single phase, and this is the case of a three phase. Okay, it was a half bridge, it is again a full bridge, single phase, and this is the three phase PWM inverter. Okay, so of course 6 devices are used, and this power circuit for square wave and PWM inverters will be same, but control scheme will be different. Okay, and finally you can get the output voltage like this. Okay, this is but here the three types of V controls required: V control A, V control B, and V control C. So V control A is responsible for the VAN voltage, V control B for VBN voltage, and V control C for VCN. Three phases. So here I have shown only A and B only, and here we can get the AB voltage. Okay, so this PWM signals, you can see the output is very close to sinusoidal. Okay, of course this particular inverters are very costly, very complex control circuits are used, but suitable for the AC applications. So this is my last slide, and finally this is the our means this particular 4 power converters we can use our renewable applications. They play a very important role. Okay, and again thanks for your patience. Thank you very much. If you have any query, please ask me. The next session will be delivered by Mr. M.M. Ansari. Just okay. Do you have any question? Please ask me. पूछो.
Participants, if you have any query, you can ask.
Okay, thank you.
Okay, thank you, Shah sir, for a wonderful session and a very informative session. Participants, within a few minutes, we are going to start with the second session, which has been conducted by Mr. M.M. Ansari sir on the topic on-grid PV solar rooftop power plant installation and assessment. So in a fraction of a second, we are going to start it.
Recording start.